All right, we're going to look at some problems from section 9.4, graphing sine and cosine functions. We're going to limit this one to not have any phase shift or any vertical shift. So we'll start out with a couple, one sine, one cosine, and then we'll add some of the phase shifts and vertical shifts in a different video. Okay, so knowing that we only have an amplitude and a period change, right? Our parent graph here would be y equals a times the sine of b theta. We are in radian mode. The amplitude, which is half of the height, is equal to the absolute value of a. And then the period for sine and cosine, because this would actually work for cosine as well, is 2 pi over the absolute value of b, because remember the period of sine and cosine, the parent graph is 2 pi. Okay, so here one of the things that I notice is that we have an amplitude of 1/2. So a is 1/2. Now I don't really like the scaling, so I'm going to change that and make that 1/4, that 1/2, that 3/4, that 1, and this will be negative 1/4, negative 1/2, negative 3/4, negative 1, and we'll get rid of those two. Okay, and I don't really like these scaling, and you'll see why in a minute. So our period is 2 pi over, here's our b value, the absolute value of 3, so 2 pi over 3. So you know what, I'm going to actually just nix that. I'm just going to draw a set of axes down here. And so if I was drawing this on a piece of graph paper, this is how I would look at it. So we're going to draw one period. So sine graph will start at 0, and one period is 2 pi over 3. And that means that it completes one cycle within 2 pi over 3. Another way to look at it is this b value, 3, means it completes 3 cycles between 0 and 2 pi, right? If we add up 2 pi plus 2 pi plus 2 pi, that's 6 pi. 6 pi over 3, which is 2 pi. So you're getting 3 full cycles. Okay, so now I'm going to look at find midpoint. So the midpoint between 0 and 2 pi over 3 is 1 pi over 3. The midpoint between 0 and pi over 3 is pi over 6. And the midpoint between pi over 3 and 2 pi over 3 is pi over 2. So our amplitude, half the height, we're going up to 1/2 down to negative 1/2. And I know the general shape of my sine curve, especially knowing that I don't have a phase shift, a move left or right. Here's a couple of my points. And we know we have this general shape. Whoop, I kind of messed that one up. This should be pi over 3, pi over 2, 2 pi over 3. So my apologies there, going a little too fast. Here, let's get that eraser. So what we should have is this point at pi over 3, pi over 2, and then 2 pi over 3. And there you can see one full cycle or one period. So our transformation is we have a vertical shrink by a factor of 1/2. And then we have a horizontal shrink by a factor of 1/3. Okay, let's look at a cosine. So again, very similar in the sense that we know our amplitude is 2. So I'm going to use this graph. We're going to go up 2 and down 2, right? Half the height. The period. So now, if we look here, this is the same as 1/4 theta. So our b value is 1/4. So we have 2 pi divided by the absolute value of 1/4. Well, that's 8 pi. So that means we complete one cycle in 8 pi, or 1/4 of a cycle in 2 pi. So our cosine graph starts here, okay, and we're going to end here at 8 pi, right there. The midpoint is 4 pi. We're going to be down here at -2. And then here we have 2 pi and 6 pi. And again, we know this is periodic, so it's going to continue this pattern. And we show the arrows, and that shows that it's going to continue, right? We'd be at 10 pi, 12 pi, and so on. So there is one period of y equals 2 cosine x over 4 or theta over 4. Okay, I hope that helps, and we'll see you soon.